We are going to be looking at transformations of functions. When we're thinking about transformations, this is where you are moving something. You are either translating it, aka a slide, or you could be reflecting it over a line. You could be causing a dilation, which is scaling it smaller or larger. You could also be doing a rotation, but specifically we're going to be looking at translations and reflections. With that, a transformation in terms of a translation is pretty simple. You're going to either have a vertical or a horizontal. We've kind of looked at this a little bit before. Let's say that our parent function is the absolute value of x. With that, let's say that we want to move it up or down. Here's what's going to happen between the two. I don't like how that looks. Okay, when you are moving it up and down, the vertical translation is going to occur as a plus or minus at the end of whatever your function has to be. So for instance, that absolute value of x, if I want to move it, it's going to be here. The absolute value of x plus or minus whatever our number is. So the absolute value of x plus or minus our shift. This is going to cause us to shift up or down. Obviously, plus is up, minus is down. Now, if we're shifting left and right, this gets a little bit trickier. This is within the function. When we're talking within the function, if I'm still sticking with that absolute value of x, my stuff is going to occur within that absolute value. So it's a difference of where it's located. Now, here's the thing with horizontal transformation or translations. They are opposite of what you see. A negative actually represents going right. I know that seems goofy because if you're thinking about it, a plus would normally designate that you're going to the right. But again, it's opposite of what you see because it's inside with that x. So a plus is then going to be a left. Function notation wise, this is what we have, f of x minus c or f of x plus c. So notice between the different functions notations, the x is closed off in parentheses right away with the vertical, where when we're talking about the horizontal, that parenthesis is extended to allot for that shift. Now let's look at this graphically. If we're looking at this graphically, I have my parent function of the absolute value of x. Right here. Okay, so this is my parent function, and we know this based on our 12 basic functions that the absolute value of x graph looks like this. So if I look at the one that I'm working with here, that y equals the absolute value of x plus 3 minus 4, to start with here, this is going to be shifted, I'm going to tell you now, it's going to be shifted down 4 because of that right there. And this, again, this is opposite of what you see. So this is going to be shifted left 3. We're going to double check it. So I did, in fact, from this vertex here, I did, in fact, shift down 4. And I shifted left 3. Okay, so now we need to talk about reflections. There are two different types of reflections that we'll be working with. We'll be talking about reflecting it across the X or Y axis. So kind of like our function notation, you're either going to have it attached with the X or not attached with the X. So let's say that my parent function is y equals x squared. So if I'm going to reflect over the x-axis versus the y-axis. Okay, if I'm going over the x-axis, this is outside. So it's going to look like, in function notation, the negative is on the outside. With the y-axis, it's going to be with the x. Okay, so function notation, we kind of get a little confused with that. So what does that actually mean? So if I'm looking at my parent function there of y equals x squared, if I want it over the x-axis, it's going to be negative, parenthesis, x squared, close parenthesis. If I want it over the y-axis, how this is going to differ is I'm going to have negative x, close parenthesis, squared. So it's just determining where that negative is actually going to affect it. So again, if I'm looking at my graphs again, sorry, I got to run over to my computer because can't quite reach that button there. So if I'm looking at my parent function, this is my parent function here of that y equals x squared. Notice this should be a reflection over the x-axis because I have that negative outside of my parentheses. So let's double check it. It should flip down, and in fact it did. So then we could add in all of these different combinations to figure out, okay, well, what is a reflection with a translation? What exactly does that look like? So we could go back and I could give you, for instance, y equals negative absolute value x plus 6, close absolute value minus 4. So if I'm looking at this right here is going to be a reflection over the x-axis. This is going to give me left 6, and this right here is going to give me down 4. Okay, so these are different situations that you're going to have to be aware of. The last one that we need to talk about are stretches and shrinks, aka dilations. Oops, one of that. Okay, with a dilation, you're obviously going to either have a shrink or enlargement. So if we have there's two different types of stretch and shrinks. We have horizontal, and then we have vertical. Let's actually, I'm sorry, I know you guys are writing this down and I'm switching it. Alright, so we're going to have like two different, this is going to be like a sub within. Alright, so let's look at just the horizontal. Basically, the difference between a stretch or a shrink is whatever our C value is. So with all of this, if it's a horizontal, it's going to be in the form of y equals f x divided by c. So you're basically giving yourself, you know, a kind of like a fraction. If the c happens to be larger than 1, it is going to be a stretch. If the c happens to be smaller than 1, it's going to be a shrink, which makes sense. Stretch is going to be larger. It's going to expand. Shrink, it's less than 1. You're talking like a fraction. Vertical stretches or shrinks. So if we were dividing with a horizontal, we're going to be multiplying with our vertical. Now, if you're having a stretch, it's going to be larger than c again. Kind of makes sense. Shrink, less than c. Again, pretty easy to tell on that. So an example here, let's say that I have the function y equals x cubed plus 12x. And we're going to do for part A, I want a vertical stretch of factor 3. So if I want a vertical stretch of factor 3, if we're doing vertical, we know that it's a multiplication. And my stretch factor happens to be 3. So this is really what we are doing here. So what that means is we are going to take that whole function, which happens to be this, times 3. All right, well, that's not bad. You just distribute. And ta-da, I have my vertical stretch of factor 3. Now, the horizontal one. This is where you got to be thinking a little bit. Let's switch it up and let's do a horizontal shrink of a half. So if we're talking a horizontal shrink of a half, our function is then going to be divided by a half. So remember, if you're dividing by a fraction or a half, you're really multiplying in that. So this is realistically f of 2 of x. So here's what makes this different than the vertical. We put the factor on the outside and then distributed. Well, with this 2 of x, that actually gets plugged into our function of x cubed plus 12x. So this is now 2x parenthesis cubed plus 12 times 2x. So it's just a difference of where that number is going to be and how you're going to approach that. So this is now going to give me y equals, I got to look at this, 2 cubed is 8. So I have 8x cubed plus 24x. So what's goofy, or what you might think is odd, you have a horizontal shrink of a half, but our numbers actually got larger. And that's because with a horizontal, you're dividing, so it's actually going to flip it a little bit. So these are our transformations of functions. We've covered translations, we covered reflections, and last but not least, dilations.